the power to which the concentration of that reactant is raised to in the rate equation. Now, order indicates how the concentration of a reactant affects the rate of reaction. And the only way to find the order of reaction is by experiments. So it's zero order with respect to A, so doubling the concentration of A has no effect on the rate of reaction. So rate is proportional to the concentration of A to the power of 0. Or rate equals a constant, which will give the symbol K, concentration of A to the power of 0. This time we're going to say that B is first order. Now if we double the concentration on B, because it's first order, the rate will double. Now rate is proportional to the concentration of A to the power of 1, or rate is proportional to the concentration of A with an invisible 1. It's up to you whether you put the 1 in or whether you don't. Rate equals the constant K times the concentration of A to the power of 1, or rate equals K concentration of A. Now this time it's second order with respect to A, so doubling the concentration of A quadruples the rate. Rate is proportional to the concentration of A squared, or rate equals the rate constant times the concentration of A squared. So if the reactant concentration doubles and it's zero order, then there's no change or no effect on the rate. If the reactant concentration doubles and it's first order, then the rate doubles. If the reactant concentration triples and it's first order, then the rate triples. If the reactant concentration doubles and it's second order, then it's going to quadruple the rate. Tripling the concentration of a second order reaction makes the rate go up by 9 times. Quadrupling the concentration of reactant and its second order makes the rate go up by 16 times. Now rate equals K, which is the rate constant, times the concentration of A to the power of 1, times the concentration of C to the power of 1, times the concentration of D to the power of 2. Now the lowercase k is the rate constant. Now the overall order for this reaction is fourth. You simply add orders. Now the units. So rearranging to make K the subject, K equals rate over that. So it's going to be moles per decimeter cubed per second divided by, now cancel one of them out, add those three together, bring it up to the top side, and it becomes dm plus 9 mole to the minus 3 s to the minus 1. It's got a fast rate of reaction. So we're doubling the concentration of A, which is first order, so we double the rate. We double the concentration of B, which is zero order, so we multiply by 1, and there's no effect on the rate. We double the concentration of C, which is first order, so we double the rate. And we double the concentration of D, which is second order, so it goes up by 4. So the overall increase in rate is going to be 4 times 2 times 1 times 2 is going to be 16. We could use colorimetry because there's a change in color. Iodide ions, which are colorless, turning into iodine, which is a brown solution. Or we could use electrical conductivity because we have 3 moles of ions on the left, but only 2 moles of ions on the right. Now the order with respect to the peroxo disulfate is first order, and iodide is first order. The overall order, now remember, you add the orders, so it's going to be second order. Now if the concentration of all reactants are doubled, the rate will increase by what factor? Okay, so let's double the concentration of peroxide disulfate, which is to the power of 1, and we're going to double the concentration of iodide, which is also to the power of 1, so it's going to be 4 times the rate. If we tripled the concentration of peroxide disulfate and iodide, then it's going to be 3 to the power of 1 times 3 to the power of 1 equals 9 times the rate. Now you may want to pause the video until you've worked that out, but it will work out to be dm plus 3 mole to the minus 1 s to the minus 1. We could use colorimetry because we've got the colourless bromide ions turning into bromine molecules which are orange or brown or orange-brown. We could also use electrical conductivity because there are 12 moles of ions on the left and 0 moles of ions on the right. We could use a pH probe on a data logger because we've got hydrogen ions on the left and no hydrogen ions on the right. So take an aliquot of the reactant mixture out and quench it using ice cold water and then titrate with sodium hydroxide. Now the rate equation from experiment was found to be that. So it's going to be first order there, and second order there. Now the overall order, remember we just add the orders, so it's going to be fourth. Now if the concentration of all reactants are doubled, the rate will increase by what factor? So it's going to be the bromate 5 is 2 to the power of 1, the bromide is 2 to the power of 1, and the hydrogen ions are 2 to the power of 2, makes a total of 16 times the rate. Now if the concentration of all reactants are tripled, it's going to be 3 to the power of 1 times 3 to the power of 1 times 3 to the power of 2, which is going to be 81 times the rate. So it's going to be 3 to the power of 1 times 2 to the power of 1 times 0.5 to the power of 2. And that equals 1.5 times the rate. So you may want to pause the video until you've rearranged that and worked it all out. And it works out to be that. We could use colorimetry because we've got iodine, which is a brown solution, going to iodide, which is colourless. We've got electrical conductivity because we've got 0 moles on the left-hand side of ions and 2 moles of ions on the right-hand side. We could remove an aliquot and then quench with sodium hydrogen carbonate and then titrate with the sodium thiosulfate. And remember, sodium thiosulfate is used to titrate for iodine. Now there's the rate equation. So if a species appears in the rate equation but not in the balanced equation, then it must be acting as a catalyst. Now the order with respect to propanone is going to be 1, hydrogen ion is going to be 1, and iodine is not in the rate equation, so it's going to be 0 order. It's going to be second order overall. It's going to be 2 to the power of 1 times 2 to the power of 1, so the rate increases by 4 times. If we tripled the concentrations, then it's going to be 3 to the power of 1 times 3 to the power of 1 equals 9 times the rate. It's going to be 0.5 to the power of 1 times 3 to the power of 1, so the rate is going to increase by 1.5 times. Now you may want to pause the video until you've rearranged that and worked it out, and it's dm plus 3 mole to the minus 1 s to the minus 1.